Okay, let's start number 2.
This car is designed to be very stable when turning a corner at high speed. Figure 2.1 shows the position of the center of mass of the car. State what is meant by center of mass. It's easy.
State what is meant by center of mass. You know it, right?
Yes.
Yeah, tell us what is the definition?
The center of mass is an imaginary point in any object where its mass tends, where its entire or all of its mass seems to act.
Okay. Then next one, please.
Say two features of the design that make the car in Figure 2.1 stable. It has a low center of mass.
What are the
And
two features?
thinking,
Yeah, B. What are the
and
two
thinking.
features? To make stable.
It has a low center of gravity, and it's exactly in the middle of the object.
By lowering the center of gravity
Yes.
and increasing the base.
Yes.
Okay, by increasing the base. All right.
Okay, sir.
Did you write that?
Yes.
Okay, so this one we have to get the center of mass, right? Of lamina.
Yes, sir. Yes.
Irregularly shaped piece of cut that is called lamina. So how will you get that?
First, we are going to drill a hole on a random side, and then we are going to um, uh, hold it with a clamp, and then attach a plumb line to it, and the direction of plumb line will give us the, we will plot a line which is just behind the plumb line, and then repeat this for different sides, and then where all the lines intersect, this is the center of gravity.
Okay, we will take 3 points, right?
Yes.
3 points at 3 corners of the lamina. Then make holes, right?
Yes.
And from each of the holes, we will let the lamina suspend freely.
Yes.
This is very important that you have to hang it in a way that it can move freely. Otherwise, it will not be in equilibrium position, right? So you
Yes,
mention it,
sir.
so that it
Okay,
can
sir.
move freely. Then after doing this, you draw plumb line. Where is the
Okay,
position of
sir.
the string? There is plumb line, right?
Yes.
That is marked by a ruler and pencil, right? And
Yes, sir.
similarly, we will do for other 2 points. And where all these lines, similarly, we'll do
Intersect.
it for the other 2 holes,
Yes.
where all these 3 lines, the lines drawn by the ruler, are intersecting each other. That is the center of mass, right?
Yes, sir.
So it's clear to you, right?
Yes.
Then we have next. Yes.
Number 3. When the lid of a freezer is opened, it pivots around about the hinge at the back of the freezer. The handle is at the front. Figure 3.1 is a side view of the freezer. The handle is 0.7 meter from the hinge. The lid has a mass of 2 kilograms. 8. The gravitational field strength G is 10 Newton per kilograms. Calculate the weight of the lid. It's easy, 20 newtons.
Sorry,
20 newtons.
20 Newton. Okay, 20 Newton is correct. Then next,
Number 2. The lid is uniform and its center of mass is at its center. The weight of the lid produces a moment about the hinge. Number 1. Calculate the moment about the hinge when the lid is closed. Okay, let me calculate this.
uh, calculate the moment about the hinge when the lid is closed, right? So here we have the
Yes,
lid and the position of the hinge is clear to us. Then
the hinge is a
what
pivot.
will be the moment? Huh?
The hinge is a pivot.
So how will calculate it?
Um,
Are you
One
using
second.
laptop?
Yes, sir.
Please annotate. How will do it?
Sure.
Write the formula, text. Huh?
Yes.
Write the formula. Then yes.
Yes, sir,
Are
I'm
you
writing.
annotating? Yeah, yeah, right.
Yes. We didn't come yet.
Yeah, yeah. Okay. It's not coming.
Yeah, now it is. So can you see the annotations?
Yeah, yeah. It's coming. It's coming.
So can you see the annotations?
So you took here 0.7.
Mm,
Would it be 0.7 or 0.35?
which one?
Hmm?
Which one? The distance.
Yeah, yeah. Distance because where will the center of mass of this lid?
Wait,
There
can you see
will
the
the
diagram?
hmm,
Can you see the diagram?
hmm.
Okay.
The
Oh,
way,
now I got it.
yeah, the way should work in the middle, right? The
Yes.
center of the lid, because
Yes.
it is uniform.
Yes. So can you see the annotations? Hello?
Yes, yes. But you should write Newton meter, not Newton per meter,
Oh yeah,
not
and I
divided.
have there are those presets that you can use. And so can you see the notifications?
Yeah, now it's all right. 7 Newton meter. Okay, so this is done, right? Part one is
Yes.
done. Now you go to next part. Yeah, continue.
The moment required to open the lid is greater than the value calculated in A1. Suggest one reason for this. One reason because the person is applying a force over here.
Yeah,
Yeah.
normally,
Person
if
is pulling the door, right? So they're applying force on the door so that we count as well.
Mhm. Normally the force required, that is for the weight, right?
Mm,
Weight of the lead. But here maybe the hinge is stiff, right? Hinge might not be that smooth, so there might be some loss of energy due to heat, right?
yes.
And that's why we require more force. Is it clear?
Okay.
Due to friction. So that could be one reason. Okay, write that.
I have taken note.
Mm. Yeah, annotate. Annotate. What you are writing, you annotate.
So can you see the notifications?
Yeah, yeah. Friction causes loss of energy. Uh, Hence, there might be more force required
Okay.
to open the lid. Yes, very good. Then we are going to next part. Yes.
Number 4. Figure 4.1 shows a screwdriver of mass, I can see, mass 64 grams resting in equilibrium on a pivot on figure 4.1. Mark and label if a C the center of mass of the screwdriver. Okay.
Yeah, wait, very simple, right? calculate the weight of the screwdriver.
Wait,
Uh,
are we not going to do number 8?
yeah, yeah. A, you have to mark the center of mass with C.
So should I annotate?
Where should be the center of mass?
Um, this one I think the center of mass is around the handle.
Center of mass is just above the pivot because there we get the screwdriver balanced.
Yes, this area.
Just
Should I
above the
annotate?
pivot. Pivot, the place where the pivot is, yeah, here is the center of mass. Yeah.
No.
Yes. Next, weight. Get the
Yes,
weight.
calculate the weight. The mass is given 640 newtons.
How much?
640 newtons.
Yeah, here they are giving you not that much easier question. It's little bit tricky. You see, the mass is given in grams. Okay, so
Oh,
you are given the gravitational field strength in kg, Newton per kg.
it's
So you have to convert.
0.64 grams.
Mhm. So you have to be careful about that, right? So what will be the weight?
0.64 newton.
Six 6.4 Newton, right? Is it
0.64 newton, right?
0.64 Newton? Okay, you the kg you are getting 0.064.
Yes.
Okay, then 0.64 Newton. Yes.
Number 2, on figure 4.1, draw an arrow labeled W to represent the weight of the screwdriver.
Okay, so where will be the W? You have to draw the arrow, right? Can you draw the arrow
The,
over there?
the weight will be above the pivot.
Yeah, your center of mass,
And the
where
center of
it
gravity are
is,
the same here.
yeah. So that position downwards will be your arrow, like this. I'm showing you. It will be like this here. Huh? This is your center of mass, right? In this position. In this position, you have center of mass. So your weight will work downwards from here. Okay,
Oh, okay.
here you can here give W. Is it clear?
Yes.
And at this position, where we label the point, there is C, center of mass.
Okay, sir.
Yeah, like you showed before, that one. Okay, done. This worksheet is done, right? Now you have any questions on this topic? Hello,
Yes, sir.
do you have any questions on this topic?
No.
So, what should we do? We should go for revision or new topic? What you want?
I think we should go for like one revision and then start another topic.
Okay, you want to go for revision now?
Mm,
Okay,
the revision for this topic.
okay, this topic revision.
Yes,
Okay, very good. Let's go for revision on this topic. So this topic is related to turning effect of forces, right?
yes, sir.
And turning effect of forces comes from the turn of the object by applying forces, right?
Yeah.
And it's the
Actually,
product
on
of,
the other previous topics that we did, I had some basic knowledge on that one, but this one is completely new to me. So,
yeah, yeah, which is completely new for you.
yes, sir.
So this one is vector quantity, right? Moment.
Yes.
Yeah, and we are calculating force multiplied perpendicular distance from the pivot. Yeah. So we have one principle of moments, where we have equilibrium. The object is in equilibrium, right?
Yes.
When when the object is in equilibrium, equilibrium means balanced. The object
Yes.
is balanced. Then if it is in equilibrium, that is for two conditions. Hmm. What are those two conditions?
The conditions for equilibrium. You know,
Yes.
um, the sum of acting forces will be zero, and there will be no resultant force, and then
Mhm.
the sum of the torque will be zero, rotation force.
Yeah, we have two conditions. First one is related to force, and
Yes.
another one is related to
Moment.
moment. Okay, so resultant moment will be zero, resultant force will be zero.
Force will be zero.
Yeah. In other way, we can say the opposite forces are equal, and the opposite forces are equal, right? And there is another one, that is anti-clockwise and clockwise
Moment equal
moment
to
are
clockwise
equal.
moment.
Yeah, clockwise and anti-clockwise moment are equal. Opposite forces are equal. Clockwise and anti-clockwise moment are equal. So this is the condition for
Equilibrium.
uh, equilibrium or balance, right?
Yes.
Yeah. So after that we have lamina. Huh? How to get the
Yes.
center of mass of a plane lamina, and we have the conditions for stability. How to make the object more stable, right? So
Yes.
these are all the things from turning effect of forces, and from here we have also some examples of our daily life, which instruments we are using our daily life. Like we have very common instrument we are using, that is stapler, right? Stapler, we are stapling the pins. If the hand of the stapler is longer, then it's easier for us to staple, right? Sometimes we are using small staplers, right? It's
Yes.
really tough to use the a smaller stapler. That time we need more
More
force.
force.
Yeah, if we are using bigger stapler, we need only small force to staple anything, isn't it?
Yes. Yes.
And in our university, we saw a very big stapler. When in our university, when we were writing for 4 hours exam, that time we were taking lots of pages. Uh, Even in our HSC level, when we are writing, especially the Bengali or English second paper, where we have to write essay, big essay, like 20 pages essay. So that time we needed lots of pages, extra pages, and we had to staple that. So that time they are using some big staplers, right? And those with bigger hand, they are stapling with smaller force. Is it clear?
Yes.
So it's not only for stapler, for anything. If you have a scissors, a pair of scissors, that time you can also, if it is bigger hand, then you can easily cut the objects, right?
Yes.
Then your doors, if you are applying force, the from the closer part of the hinge, then it will take more force, right? But if you are applying force at the other end of the hinge, right? That means other
Yes.
end of the door where the hinge is very far from the position where you are applying force. That time you can move it quickly, right?
Yes.
Move the door quickly. Easily you can close or open it. This way, movement is helping us to uh, get the benefits our in our daily lives, right?
Yes.
So these are the main things of movement, and using these all ideas and formulas, we are having the questions, huh?
Mm.
Our worksheets. We had the worksheet, and here is the formula. We have, yeah, yeah. This is not that much, more thing here. All these things are done. So that's the revision of this topic, theory part, and now we can go for the worksheet part and some MCQ questions, right? Oh, worksheet, not this one. So this one you were a little bit confused, right, when you are answering. Now it's clear to you, right? What is the answer of this question one?
What which quantities
Hmm.
making the volume of the object?
Volume of two objects. Other things, uh, you see
They're the
mass.
same. The
Yeah,
mass will be
same.
the same. The
Yeah,
moment will be same because
as
the
our
distance is the same in both sides.
the first thing is the distance from the pivot for both the objects are same, right? So if they are balanced, that means clockwise and anti-clockwise moments are equal,
Yes.
isn't it? This is the first
Yes.
thing. And if the clockwise and anti-clockwise moments are equal and the distance are same, that means the forces working, those are also equal,
Yes.
isn't it? Force
Yes.
means weight here. That means weights of the two objects are equal. Then if weight is same, then we have the product of mass and gravitational field strength is weight, right? If weight are equal, in the same place we have the same gravitational field strength, isn't it?
Yes, sir.
And if
So if the
so,
gravitational
the
field decreases, it will
yeah
increase in both sides and
yeah
it will get
now
lesser. So
now they are in the same place. So they have the same gravitational field strength. As they have the same weight, same gravitational field strength, of course they have the same mass, isn't it? So first thing is moment. We are using the idea of moment, and from that moment we are going to weight. Then from weight we are going to mass step by step,
yes,
and we found that all three A, B, D, they are equal, right? Moment equal, weight
yes,
equal, mass equal. And what could be different? That is volume, right? Mass,
yes,
we have lots of examples that if mass are even equal, then volume might be different of two objects.
yes,
Yes. So this one is our answer here. This is also you can remember, right?
yes.
C is our answer.
I made a mistake here.
Yeah, here you chose B first.
D, yes,
Hmm. Then this one also we have maximum turning effect in A, right?
yes. The distance is the greatest in A, and the both forces are equal, so it will have great turning effect to the other ones.
Hmm. Then we have this one using the turning of effect of forces balance, right? Clockwise and anti-clockwise movement balance. That one we are using here. 600 multiplied by 70, the distance from the pivot. Then F multiplied by 120, right?
120, yes, addition of 17.
Uh, the students are making mistake. They are taking only 50. Hmm.
That will be a grave mistake.
Yeah, we have to take it from the pivot. This one was easy. Then this one was a little bit tricky, right? We have to take the distance for the weight of the object from the center of the board, right? That is the
Yes,
tricky part. That is 1 meter, right? The distance from
yes,
the pivot will be 1 meter. Then if you add, it will come 1500.
yes,
Then this one was the most, tricky part, right?
yes.
Yeah, most difficult questions. So what was the answer for it?
No,
Yeah, what is the answer of it?
the answer is so wait, let me think.
Mm-hmm. You forgot.
No, I remember.
Mm. Can you try this one? What should be the answer and explanation also?
Yeah,
Yes, Adrita, are you trying?
yeah.
Adrita, are you trying?
I'm trying.
Yeah. So we will continue, huh? After the break, huh? We will start 5:45.
Okay, sir.
Okay?
I'm gonna be sticking my calculations somehow.
Yeah, yeah, do it. You finish your
Yeah.
calculation, we'll start 5:45. No
Okay,
problem.
sir.